Hello track and everybody else that is gone that's requested this video. This is just 39 of the review. This is the last problem and it is a doozy. You will need pretty well this entire area to write with, so kind of write a little bit small. 39, we have two vectors and we are trying to find the resultant vector, which means the vector or the way that this thing is going to go when you have these two forces pulling on it. So like they said, I don't know if I have a stake that's in the ground, you know, like one of those things that you're trying to pull out of the ground, and somebody has a rope that's pulling this direction and somebody that has a rope that's pulling this direction. Where is the stake going to fly out of the ground at?
No.
Probably like in between the two, right? The stake's going to pull out of the ground in between the two if they're pulling kind of at an angle toward each other. Closer to which one?
Neither. They're the same.
Neither. They're the same, right? So like basically right in between the two, right? And you can probably figure that out in your head, like right in between the two would be like probably straight up and down, I'm guessing, at a 90-degree angle, but we'll see if that's going to work. So what we need to do is we need to look at the vectors in component form. But before we do that, let's do this, okay? I'm going to teach this to you just a slightly different way that's going to make hopefully a little bit more sense, okay? And we're going to write each of these vectors out in polar form. So let's say vector 1 and let's say vector 2, okay? Vector 1, let's call this guy, and this guy's vector 2, okay? The first one's pulling to the right, the second one's pulling a little bit to the left at those angles with that amount of force, okay? When we're doing polar form was the r times cosine theta plus I sine theta, right? We're going to write each one of these vectors in their appropriate polar form, okay? So vector 1, what is the r? On vector 1, what's the r value? What does r stand for? The hypotenuse. R is the magnitude. So what's the magnitude of vector 1? 115. That's a magnitude. So we have 115 times cosine of the angle. What's the angle for vector 1? 60 degrees plus I times sine of also 60 degrees. Okay, vector 2, what's vector 2 going to look like?
Same thing.
Same thing, but
120.
But 120 degrees instead of 60 degrees. Okay? All right, now we can easily go from polar form to component form, which is these like little triangular brackety things, right? How do you do that? We had to do it up above. How do you go from polar form, which is that guy, to the x and y coordinate form? You just plug it in. So 115 cosine of 60, 115 sine of 60. 115 cosine of 120, 115 sine of 120. That gives you your x and y coordinates. And there we have those two things. Okay.
115 cosine of 60 is 57.5.
57.5. Okay. And 115, sine of 60. 99.6. Okay. All right, now do the same thing for 115 cosine 120, 115 sine 120.
Negative 57.
Negative 57.5.
And 0.5. And then it says plus 99.5. So it's 99.6.
99.6 that way. Okay.
Oops. Oh.
Okay.
Wait.
So there's what's happening with those two things. Those are my two forces, and they're in component form. And when they're in component form, we can do like what we did on 37, right? We have our component form of our two vectors, and we can add them together like we did here, right? On that was on 37. We can add them together, right? Or subtract them or do whatever we need to, right? So we have them in component form now, and we can add them together. We want to combine the two forces because they're both pulling on that same object. So I want to just add those two forces together. So it's going to be 0, comma, whatever that is, 190 something maybe, 198.8, 199.8, 199.8, okay? And then from there, that's where the resultant vector is going to go. So 0, 199.8, you can think about where that's going to land. If we're going to the left and right, 0, and we're going up 199.8, that means it's going to go straight up here. Oh, 199.2. I don't know what I'm thinking. Fix that. 199.2. There we go. It's going to go straight up in the air, though, right? 0, 199.2 is going to go straight up in the air. Yeah? Now they want us to find the magnitude and the direction of that. Okay? So we need to find magnitude, and we need to find direction. Okay? Magnitude, direction. And this is the same as problem number, I don't know, we did this a whole bunch of times. Problem number like 35, we did magnitude and direction, but that wasn't in rectangular form, 3 minus 6i, but it could be rectangular form, like 3 comma negative 6, magnitude direction of that. Or same thing with 40. We did basically magnitude, no. Was it magnitude direction of that? 38? Yeah, we did magnitude direction of that guy, right? So same thing there. Now in this one, it's really nice because we have 0 there. Normally when you're finding magnitude, you do the Pythagorean theorem, right? So it would be like 0 squared plus 199.2 squared equals c squared, and you would take the square root of that. Do you know what that's going to give you? Just 199.2, right? Does that make sense?
Mm-hmm.
Okay?
Yeah.
Because 0 squared is 0, 199.2 squared, and then the square root of that is just going to stay 199.2. So 199.2 is the magnitude, and that's kilometers per hour. That is the force that is being applied to this whatever stake that we're pulling out of the ground or whatever. Okay, 199.2 is the force. And normally to find direction, we do tangent of the x over the y. So normally we do inverse tangent. Like tangent of theta is equal to the x over the y. Is it x over y? No, y over x. Tangent of theta. Direction. Tangent theta equals y over x. So tangent of theta equals 199.2 over 0-ish, whatever that is. And we do inverse tangent, right? What's inverse tangent of 199.2 over 0? You could do this without having to do this process. Because what's the direction going to be?
0. No.
Does it say 90 degrees on your calculator?
I can't divide by 0. Mine says error.
Yours says error, syntax error, because it doesn't like dividing by 0.
Yeah.
Theta is 90 degrees. You can't divide by 0 because what is dividing by 0?
Wrong.
What is it? What is it called?
That's the thing you can't do.
Undefined. Okay, if you look on your unit circle, do you guys have your unit circles handy? Okay. Caleb's got it right
It's
here.
90 degrees.
Where is tangent undefined at?
90 to 70.
90 degrees or 270, but this is going to be straight up. It's going to be 90 degrees, right? Okay.
Correction.
So you can do that way. Or you can just think about what it looks like. Where is 0, comma 199.2? That's going to be straight up and down. That's at a 90 degree angle, right? Okay, so 90 degrees is the direction, 199.2 is the magnitude. Now, so that one was a little weird just because that 0 was there, but it would be the same thing. You would do the inverse tangent if you had a number here instead of 0, right? You would treat it exactly like what we did up here, magnitude, direction. Yeah? Okay, so putting them in polar form, those two vectors in polar form first will help. Putting them in component form, adding them together, then doing the magnitude direction. So it's just a few more steps. It's like adding, like doing 38. It's like a combination of problem 38 and, I don't know, problem, I don't remember which one we did. 38 and 35. Oh, no, 38 and 36. Because that one you're finding the component form. So we went from polar to component form, okay? So you're doing 36 and then you're doing 38 to it. So it's magnitude, direction. It's like combining those two problems together, okay? How was that?
Good.
Ish, okay? That's what he's got, okay?
Why?
All right. Can I stop recording? Anything else we need to add onto that? Did that make sense? Was that okay? It's a lot of steps, but It's just like two problems combined into one, right? Okay, goodbye, everybody.